A cardiovascular disease is all too common here on Earth, claiming more than 600,000 lives a year. But on board the International Space Station, there's an experiment underway studying the cardiovascular systems of the station crew members. This experiment is called CardioOx and could lead to important information that will benefit future long-duration space travelers, as well as people who never leave the planet. From the Marshall Space Flight Center in Huntsville, Alabama, my colleague Lori Meggs reports on a recent trip to the cardiovascular lab here at JSC in Houston to learn more.
CardioOx. It doesn't sound pretty, but Stuart Lee tells me it's something that we really need to investigate. Tell us what we're studying.
So our objective is to understand the effects of spaceflight on the cardiovascular system. And in this particular case, we're interested in the effects of spaceflight on cardiac health, and specifically in the arteries that supply our heart and the rest of our body. So does the spaceflight environment promote a environment within the body which might increase the progression of atherosclerosis?
Have we done this before? And what is atherosclerosis? I don't know that I can even say it right.
So atherosclerosis is what most people refer to as hardening the artery. So it's the normal progression that the body goes through of essentially moving lipids into the walls of the vessels, which in some cases, in extreme cases, would lead to a heart attack.
And can you show me how it works? I think I want to be a test subject.
Yeah, this is a great opportunity for you to see a little bit about what we do in the laboratory and experience it for yourself.
So I feel like I'm giving blood, Stuart. What's happening now?
So you're not actually giving blood, but we're going to measure the blood flow in your arm. And so some of the effects of cardiovascular disease is it changes the way your blood vessels react to changes in flow. As you need to increase flow in different parts of your body, you want your blood vessels to be able to dilate. And so that's what this experiment's all about. What we're doing is we're going to measure the blood flow in your arm at rest, so what it would normally be just when you're laying here. Then we're going to include the blood flow in the bottom part of your arm. What that does is it creates a metabolic stress in the bottom part of your arm, so your body wants to get blood flow to that part of your arm. So we normally leave that cuff on for 5 minutes, and then we release the cuff. And that causes that rush of blood into the lower part of your arm. And so as I mentioned, the artery in your arm, measuring the brachial artery right now, should vasodilate. It should expand to accept that extra blood. If there's problems with the function in the artery, we won't see that expansion. And that lack of expansion or dilation of the vessel is indicative of the progression we're progressing to atherosclerosis. This is a surrogate, essentially, because we can't do this in your heart. It's not very much fun. They do it clinically, but we wanted to do it non-invasively, so we're using the brachial artery as a surrogate for the coronary arteries in your heart.
So what are we learning from this?
So the idea is we're trying to understand whether our crew members, whether we're putting them at increased risk for cardiovascular disease, specifically atherosclerosis, as the result of the spaceflight environment. Then that when they go on orbit, I mean, they're older individuals, so they're in the 40 to 50-year-old range, so they're already starting to show signs. In a normal population, they would be showing signs of atherosclerosis. But are we accelerating that process by exposing them to radiation, changes in their diet, additional psychological stress, anything like that, which we would normally associate as a risk factor on the ground for development of cardiovascular disease? The question is, does the spaceflight environment make that worse?
Do you think there are stresses more with spaceflight that could lead to cardiovascular disease?
So we don't think there's anything that happens in flight. Like, we're not expecting a crew member to have a heart attack just because they go into space. But we're concerned is the long-term health effects, the occupational health outcomes. And so, one of the big issues that we're anticipating is based on some pilot data that was collected in another laboratory, that the amount of oxidative stress and inflammation appears to increase with spaceflight. And those are the precursors to atherosclerosis. Those are usually the first steps to the development of changes in what we call hardening of the arteries or plaque development. But those are usually over short, long periods of time, where we're looking at a snapshot during spaceflight, but we're also then following the crew members for 5 years after they come back. so we get a more long-term picture of their cardiovascular health.
So is this strictly for space flight, or will this have Earth applications, what we learn?
So the procedures that we're using in this experiment actually are used clinically to track the progression of atherosclerosis in some individuals. It's used in multiple studies looking at population-wide changes, the effectiveness of different interventions to prevent atherosclerosis. And so it's not something that we're actually doing it the opposite. We're taking a technology that is normally used on the ground, and we're taking it to space to study our astronauts.
And you're also part of the twin study too, right?
That's exactly right. So we're afforded a very unique opportunity to study the twins. The advantage of obviously studying twins is you're essentially studying the same person on the ground and on orbit. And so now we can see, in this particular case, does Scott react differently than Mark as a result of being in space for a year?
Do you mean that they laid here and went through this like I have too?
Oh yes, they've both been in here for this experiment. They're very excited to see our results. They learned something about themselves in the process. And of course, the other part of the twin study is that we're teaming up with group, specifically in our area, with for a group from UC San Diego, and we're looking at the genetic profiling and how the changes in spaceflight, or how spaceflight might change the way that our genes are expressed, and then how that in turn results or might be related to changes in the way your body responds to stresses like this.
So that's it? What am I going to learn from this?
Well, we learn a little bit about the atherosclerosis, and we're going to learn a little bit about how, not just how it applies to our astronauts, but also how it might be indicative of changes in our, the normal population on Earth.
I got a good heart, right?
Well, we hope so.